Okay, so this is going to be a brief video on the graphs of the cosecant, the secant, and the cotangent functions. So recall that the cosecant is 1 over the cosine, or sorry, 1 over the sine. So let's actually get the sine function up here because it's going to be helpful to have that when we're looking at the graph of the cosecant. So the sine is here. Remember, the cosecant is going to be 1 over that. So wherever the sine is equal to 0, there's going to be an asymptote for the cosecant. So let's draw in a couple of those asymptotes. One is going to be when x is equal to 0, right? There's one. There's a little blue line there on the y-axis. One will be when x is equal to pi. So there'll be another one. And let's get one more here. X will be 2 pi. So it seems that where these vertical lines are, if I go over one period of the cosecant function, I should have asymptotes there. And if you look, and if I draw y is equal to the cosecant of x, lo and behold, I do get a function with those asymptotes. So if you look, the sign changes on each side of those asymptotes. The entire function has a period of 2 pi still. And if I get rid of the sign, you can see that there is just the cosecant function. So this is what the cosecant function looks like in the plane. You can do this also with what do you call it? This will also adjust with like changing the amplitude, changing the phase, changing the vertical and the horizontal using the A, B, C, and D parameters, just like we did with sine, cosine, and tangent. Alright, so let's turn all these off. That gets us kind of through the cosecant, and now let's look at the secant. Now remember, the secant builds not off of the sine, but off of the cosine. So we're going to turn this on. But my asymptotes are going to be at different places. Now they're going to be at like negative pi over 2, pi over 2, and let's put a third one in at 3 pi over 2. Okay, so let's turn those asymptotes on. So there they are. This is where the cosine is equal to 0. So this should give me division by 0, and the cosecant, or the secant, should not exist at those points. And let's see what the secant looks like. Now, you'll notice that the secant looks almost identical to the cosecant. Okay, so let's get the cosecant back up there so you can see it. They look almost identical, but they're off by pi over 2. So the secant is pi over 2 to the left of the cosecant. Let's turn that back on. You notice that you get the division by 0 wherever the so the division by 0 for the secant is wherever the cosine is equal to 0. And if I turn off the cosine, this is what the secant function looks like. So not too bad. All right. So let's talk about the cotangent, right? So again, we're going to turn these all off. Now, the cotangent is 1 over the tangent. Okay, so recall, if I draw the tangent function, it looks like this. Okay, so that's okay. But note that the tangent is also 1 over, is actually the sine over the cosine. So the cotangent is going to be the cosine over the sine. So what's important to us here is actually the sine function. I'm going to bring the sine function back up, and we're going to look again where the sine function is 0. So just like before, the sine function is 0 at x equals 0. All right, so let's turn that one back on. X is equal to pi. Turn that one back on, and x is equal to 2 pi. So we can turn that one back on. So we would expect the cotangent. Now, if you look, that's where the tangent is equal to 0, is at those 3 points. Okay, so where the asymptotes are, the tangent is equal to 0. But the cotangent does not exist at those points, right? So, oops, that's not the cosine. I want the cotangent. There we go. The cotangent does not exist at those points. So it looks almost identical to the tangent, but the asymptotes, instead of being at negative pi over 2 and pi over 2, are now at 0, pi, 2 pi, and the function is now decreasing. So let's get rid of the sign for a minute. So this is just the cotangent function. Note, the cotangent is decreasing while the tangent would be increasing. And the asymptotes are in different places. So the cotangent's decreasing, the tangent is increasing. Now if I put them together on the map, you can kind of see, ooh, wait. Alright, they're playing with different asymptotes. There's some crossing and some intersecting there. It's not entirely useful to do this, but it gives you an idea that they're going almost in the exact opposite direction. So this one is the graph of the cotangent of x, and there you go. So let's do some exploring with that.